Hello. This short lecture will be on average product. Let's start by remembering what a production function tells us. So a production function simply gives us the output as a function of the inputs, which we typically think of as labor and capital. Now, the average product is simply the output per unit of a specific input or factor. So let's take labor as an example. The average product of labor, which itself will be a function of labor and capital, equals total output of that labor and capital over labor. So just as an example, suppose that there are 10 units of labor. So there are 10 people working in the factory. And suppose that output is 100. So Q is equal to 100. Then average product of labor is simply the average amount of output that each person accounts for in the production process. So it's 100 over 10. Or in other words, on average, each person is producing 10 units. Likewise, average product of capital equals total output, F of LK, over K. All right, now let's look at this graphically. I'm going to draw a picture here where I have on the x-axis labor and on the y-axis output Q. And let me graph the production function. So output as a function of labor might look something like this. There's F of LK. Now we're going to be looking at the average product of labor here. So let me hold capital fixed at some value K bar. All right, and I want to look at average product of labor now as a function of L and K bar, which again is F of L K bar over L. And let's, for illustrative purposes, take a specific amount of labor. Let's call it X. Here it is there. And look at the output associated with X. That's here. There's F of X K bar. And we want to figure out how in this picture we have average product of labor represented. Well, what is average product of labor? It's the total output, in this case F of X K bar. That's the distance between the origin and this point here, over the amount of labor we're using, which is X. So you can see that if I draw a line connecting this point with the origin, that's a straight line, the slope of that line is exactly average product of labor. It's F of X K bar, that's the rise of the line, over X. As examples, let's look at the standard form production functions. The first example is the linear production function. Remember, that's F of LK equaling AL plus BK, where A and B are constants. Here, the average product of labor, just take that as an example, capital will work the same way, as a function of labor, holding capital fixed at K bar, equals this expression divided by L, so that's AL divided by L, which is A, plus BK divided by L, which is B times K over L, and of course we're holding K fixed at K bar. The second production function that we dealt with is the Leontief production function, where F of LK is the minimum of L over A and K over B. Again, A and B are constants. And here, the average product of labor, holding capital fixed at k bar, will be a little bit more complicated expression, because you recall that with the Leontief production function, there are two parts of the labor space you have to deal with. When L is really small, the minimum of L over A and K over B will be given by L over A. And when L is large, the minimum of these two things will be K over B. So to account for that, we have two regions. For low values of L, the output is just L over A. And we're looking for the average product. So it's L over A divided by L. That's just A. Where is that valid? Well, it's where L is less than or equal to A over B times K bar. For L greater than A over B times K bar, we have that the minimum of L over A and K over B is just K over B. So writing that, K bar over B, dividing by L, because we're looking for the average product, we have K bar over BL. Now the third case is the Cobb-Douglas form. Remember, the Cobb-Douglas production function has f of Lk equaling capital A, L to the little a power times K to the little b power. And this one's very straightforward. The average product of labor here, as a function, of course, of L holding K bar fixed, will be equal to this thing divided by L, which is A, L to the little a minus 1, K to the little b power. All right, and then the last production function of the standard form that we look at is that CES production function, where f of Lk equals L to the rho power plus K to the rho power, all of that to the 1 over rho power. Okay, now here, again, we're just dividing this by L for a particular amount of capital held fixed at K bar. So the average product of labor here equals this expression over L. And doing a little bit of algebra, which you should do, you'll find this comes out to be 1 plus K to the rho power, L to the minus rho power, all to the 1 over rho power. So as I said, you should do that calculation and make sure you get that answer. That's all for now. Take care.